All right, welcome back. So in the last video, we talked about the rules governing preferences. And in this video, we're going to think about how to show those preferences graphically. In particular, how to deal with situations where instead of choosing between two discrete options, right, a mask or a frisbee, we're going to choose between a continuum of different options. So to think about this, why don't we take a really simple example? Let's imagine that you're deciding between different combinations of American dollars, right, US currency, and I think they've got a term like tiger taps or something like that, but I'm going to call them oxybucks. Basically the points that you can use to buy food in the dining halls. So if we want to think about all of the different combinations of oxybucks and dollars, right, we could draw them on a graph, right? So we could have oxybucks and we could have dollars. Right down here, we've got 0 of both. And let's say, we're going to include everything 0 to 10 of each of these. But of course, these, go on forever. So in general, we could draw any point, right? Any number of dollars and bucks could be represented on this graph. And we want to know about our preferences over different combinations. We'll say my preferences over different combinations of oxy dollars or oxybucks and US dollars. So let's imagine that I wanted to know what are all the combinations that I like better and that I like worse than $5 and $5. Now, I think we can probably all agree, right, because more is better definitely applies in this case, probably all agree that anything where I get more than $5 and more than $5 is going to be better. We can probably also agree anywhere where I get less than $5 and less than $5 is going to be worse, right? I would prefer more money to less money. So that's going to be the first simplest thing we're going to say. But for me personally, I'm going to take this another step. Given my preferences, if you give me a few extra dollars in either form, I'm probably going to spend them getting a slice or two of pizza over at the Tiger Cooler. So I don't really care if you give me money in the form of oxybucks or if you give me money in the form of dollars, because I'm going to spend them all the same way. As a result, for me personally, I'm going to be happier with any combination of dollars and bucks that adds up to more than 10 than I would be with any combination that adds up to less than 10. Right? In other words, if I'm thinking, what would I trade $5 and 5 oxybucks for? Anything where I get more than 10 total. So that includes getting getting more than 10 oxybucks and no dollars. It includes getting more than $10 and no oxybucks and everything in between. So if I drew a line like this, right, I could say that everything up here is preferable to $5 and $5 for me, and everything down here is worse than $5 and $5 for me. Right? You might not agree, you might have a strong preference for one or the other, but for me, this is going to represent my preferences. Now, what I've done by drawing this graph is essentially, I've taken every single one of these preference relationships, right, where I say A is preferred to B, if I call this A, and this point B, and this point C, right, I've done the work of drawing out every single combination of A is preferred to C, B is preferred to A, et cetera, that anyone could draw, right? I've now compared 5 and 5 to every feasible combination of dollars and oxybucks that I could potentially have. And what I'm going to say, right, everything above is better, everything below is worse, everything on this line I'm indifferent to, right? I don't care if you give me A, or if you give me D, or if you give me E. So I'm going to call this line indifference curve. What's an indifference curve? It's a line or a curve that separates better from worse. Everything above the indifference curve is better than everything on the curve. Everything below the indifference curve is worse than what's on the curve. Everything on the indifference curve is just as good as everything else on the indifference curve. And now the reason I'm going to call it a curve, right? The reason I'm calling it indifference is obvious, right? It's because I'm indifferent to everything on here. The reason I'm going to call it a curve instead of a line is because most of the time it's not going to be a straight line, right? It's only a straight line here because I personally don't care if you're giving me dollars or bucks. Now, is what we've done so far sufficient to fully explain, fully express my preferences between dollars and bucks? Not really. It's enough, this is enough to fully express my preferences between $5 and $5 and any other option. But I might want to know, what do I like better and what do I like worse than 4 and 4? Right? Or 6 and 6? Or 9 and 0, right? 0 and 9. What I can do is I can draw an indifference curve for all of those options as well. Right? If I care about 4 and 4, I can say what are all the combinations of bucks and dollars that are as good to me as $4 and $4, right? And it'll be anything where the sum adds up to 8. If I look at 6 and 6, right? Anything where the sum adds up to 12, right? If I look at 0 and 9, anything where the sum adds up to 9. So I don't just have one indifference curve, I actually have potentially infinite indifference curves, right? For any particular choice that you start with, any particular option you want to consider, I can draw a curve that separates better, worse, and indifferent, right? And so instead of just drawing these regions, right, the region of better and the region of worse, I can say, in general, there's a big arrow going this way towards better, right? The higher the indifference curve you're on, the better you are. So everything on this indifference curve, right, is going to be better than everything on that indifference curve. Everything on this indifference curve is worse than everything on that indifference curve, right? Because as you go higher, you get to better and better and better options. And now, once we've done this, once we've drawn a curve through every possible point, now we've done the work of fully expressing my preferences between Aussie bucks and US dollars. Okay, so as I said before, the example we just went through, right, with US dollars and Aussie bucks is a little bit weird because of the fact that I don't really care whether I'm getting dollars or bucks. And as a result, we have these indifference curves that are perfectly straight lines, and we could explain objectively why it is that I preferred $5 and $5, right, to say $9 and no bucks. But in most circumstances, our preferences are not going to be explainable in that way. They're going to come from inside of us, right? And my preferences and your preferences might look very different from each other. So as an example of this, let's imagine that this weekend, we're going to have some amount of leisure time, right? We're going to spend that time either talking to our friends, hanging out with our friends, well, hanging out is illegal now, right? Talking to our friends on Zoom or Skype or whatever, or watching television. We've got time with friends, and we've got TV. Right? We can imagine whatever time you're not spending this weekend, either talking to your friends or watching TV, you're going to spend doing some unpleasant chore, right? You're going to wash the dishes, you're going to do laundry by hand, you know, sort scrap metal, whatever it is for you, right? So you'd really prefer to spend your time doing these activities. Let's imagine that we wanted to draw indifference curves that express everything that's better or worse than some initial option. Like let's say 5 hours with your friends, 5 hours of TV, right? So we're going to start here. We want to know everything that's as good to you as spending 5 hours with your friends, 5 hours watching TV over the course of a weekend. So for me personally, right, if I thought about how much time with my friends would I need in order to totally give up the TV time, well, I'm a little bit introverted, right? I need a little bit of time to recharge after spending a lot of time with my friends. So if I was going to give up these 5 hours of TV time, I would probably need more than 5 hours of friend time to make up for it. I might want to go all the way to having, say, 16 hours of friend time. So I might be indifferent between these options, something like this. But likewise, right, if I'm not going to see my friends at all or not going to talk to my friends at all, after a while of just sitting by yourself in the dark watching a TV show, you start feeling a little bit sad, a little pitiful if you're me. So in order to give up my 5 hours of friend time, I might need more than 5 hours of TV time. Let's say I need 12. Right, so I might have an indifference curve that looks something like this. Maybe we could throw a couple other points in there too, right? I have 8 hours of friend time, maybe with 3 hours of TV time, etc. Right? To draw a curve, just like before, it's going to separate better from worse. So we're going to have better up here. We're going to have worse down here. And just like before, everything on the curve is just as good as everything off the curve. The only difference between what we're doing now and what we did in the last example is that now I can't tell you mathematically, right, why it is that I drew the curve the way I drew it. It just comes from my own preferences, and your curve might look different. Okay, so looking at this, I want to use this to express a couple of general properties of indifference curves, because the shape that I just drew here is going to be a shape we're going to see a lot of. And it's a shape that essentially represents these 4 properties we expected preferences to have in the first video. So the first 2 properties are going to come from the assumption that preferences are rational. So first of all, right, we know that preferences that are rational have to be complete. In other words, I can always tell you whether something's better, worse, or the same. What's that going to look like in an indifference curve? Well, that's going to look like I can pick any point, and I can draw an indifference curve through that point. Right? Any point on here, I can draw an indifference curve, and by doing so, I'll tell you everything that I prefer to that point, everything that I prefer that point to, everything where I'm indifferent. So the first indifference curve through every option. Because of completeness. Okay, so our second property, right, our second property of preferences is that they have to be transitive, right? That our preferences have to be consistent with each other. We're going to represent this in indifference curves by saying that indifference curves can never cross. To show you this, let's imagine that I did have indifference curves that crossed. So let's say that I drew another indifference curve that looked like this. And I'll draw out some points like point A, point B, point C. Well, let's think about what this is telling us. So if I have indifference curves that look like this, I know that A and B are equally good, right? So that means that A is just at least as good as B. I also know, right, that C is at least as good as A, because they're on the same indifference curve as well. Well, if our preferences are transitive, this should imply that C is at least as good as B. But B is on a higher indifference curve than C, right? If we look here, even though they both are on the same indifference curve as A, B is above C. But this is not true, right? So if we have indifference curves that cross, our preferences are violating transitivity, right? Our preferences aren't going to be consistent with each other. So our second property, indifference curves never cross each other. I should really be careful here. I should say a particular person's indifference curves never cross. So I'll erase this so that that doesn't drive us crazy. Okay. So this is what it means for preferences to be rational. But we also said that preferences are going to be well behaved, right? So what does it mean for preferences to be well behaved? Well, one thing is that more is better, right? If more is better, you're always happier with more of something that you like than you would be with the same of everything else, but not getting the extra bit of something that you like. Then we always know that if we draw a straight line up from an indifference curve, everything on that straight line has to be better. What that implies is that the indifference curves themselves have to slope down. Why is that? Because the indifference curve is telling us all of the different combinations that are equally good. So if I get more of one thing, right, more TV time, in order for me to be indifferent, I have to give up some friend time. If my indifference curve sloped up, that would mean that I'm indifferent between having more of both and having less of both, right? So indifference curves downward sloping. This is a result of more is better. And then lastly, right, we have diversity is better, right? We would rather have a mix than to have all one thing or all the other. The way that this is going to be represented in indifference curves is that indifference curves bend away from the origin. Another way of thinking about this, right, is that the slopes, we think it almost looks like they got pulled in, right? If we take 2 points on an indifference curve and we connect them with a straight line, which is to say we consider the average between 2 points, right, point A, point B, and then point C is the average. The average is always going to be better than the extremes, right? I'm happier with a mix of TV time and friends than with almost all friends or almost all TV time. So for indifference curves bend away from the origin, this is another way of saying prefer average of 2 choices. And this is going to be the graphical representation of the rule that diversity is better. So if the opposite was true, right, the more time you spend watching TV, the less you want to see your friends, we would have indifference curves that look like this, right, that bend in the opposite direction. In this case, if we drew a line between 2 points, the average of 2 options would be worse, right? This means I like extremes. Okay, great. So this is all I'm going to say about indifference curves. This is going to be how we graphically represent people's preferences. What I'm going to do in the next video is I'm going to walk through how to take this graphical representation of preferences, the work we just did in indifference curves, and use it to represent preferences mathematically in equations.